we're going to start with chapter 2.2, which is polynomials. And we'll start with just the basic. If it's even and has a degree of 2 or greater, then it's going to look like the parent function f(x) equals x squared, and they'll go this way. And if it's positive, it'll go this way, but if it's negative, it will go this way. And then if it's a polynomial with a degree of 3, or if it's just an odd number of 3 and greater, then it'll go this way. But if it's odd, it'll go the opposite way.
If it's negative, you mean?
Negative, it'll go the opposite way. And we'll just start out with an example of an odd and positive one. And so the rules of polynomials would be the first to find the zeros, which would be -1, -1, and 3. To find the degree, which is 3, which is odd. To find the lowest coefficient, which is 1. And the y-intercept, which would be -3. And this is how the graph would look. And remember that it would bounce because it's odd and it has multiple x plus 1s.
Let me just say that LC should be leading coefficient, not lowest coefficient. That's
leading
fine.
coefficient.
Yes.
And example 2 is of an even and positive one. You follow the same rules, except since it has a degree of 4, it will look like the parent function f(x) equals x squared. And it'll come out as this. On 2.3, we're talking about long and synthetic division. And the rules of division for long division is finding the zeros of f(x) using a calculator, find your factor, set up an equation, and if you get a remainder, it will not be a factor. And it's only one rule for synthetic, which you can only use it if you have x minus 8, or like x minus 2, x minus 3, that type of thing. And with right here, long division is x minus 2 divided by 6x cubed minus 19 squared plus 6x minus 4. And you get 6x squared minus 7x minus 2. Do you want me to explain it?
I think it's good.
And then we can also do this as synthetic also because it's x minus 2. And this is what you would get. To explain it a little bit, you would bring down a 6. 6 times 2 is 12. -19 plus 12 is -7x. 7 times 2 is 14. 16 minus 14 equals 2. 2 times 2 is 4. -4 plus 4 equals 0. And you get the same answer as you would with long division. Over here, we'll be talking about complex numbers and zeros, which is 2.4. And to start off with complex numbers, you can get a review on imaginary numbers and real numbers. And that would be I is the same as the square root of -1. I squared equals -1 also. And then -1 times the square root of -1 times the square root of -1 equals 1. And I cubed equals -I.
Let me just, I think square root of -1 times square root of -1 should be -1. There should be a negative in front of, yeah, right there. Cool.
Thank you for the correction. Then we can do complex conjugates. Which would be A plus BI times A minus BI, which will give you A squared minus ABI plus ABI minus B squared I squared. And that will end up giving you A squared plus B squared, which will give you a real number. And then we can do dividing and simplifying. Which is you're getting rid of the I in the denominator. So an example would be 5 plus 7i 3 plus 2i. And to get rid of the denominator, you will multiply it by 3 minus 2i. And that would equal 15 minus 10i over 13 plus 21i minus 14i squared. And that would give you 3 squared plus 2 squared over 4. So that gives you 29 plus 11i over 13. So the denominator no longer has an I in it. That was a little review on imaginary numbers and real numbers. And now we'll go into the complex zeros. So with the complex zeros, it will always come in conjugates. An example would be fx has the zeros of 1 and 2 plus 5i. And to find fx, you do x minus 1, x minus 2 plus 5i, and x minus 2 minus 5i. And the complex zeros, an example of that would be x squared plus 10 equals 0. X squared equals negative 10. So it would be x plus or minus 10i. Another example would be fx equals 2x plus 1. So it would be equals 2x plus 1 half. And then that would equal the zeros would equal x, which would equal negative 1 half. And we can also talk about expanding complex factors. So say you have an example of x minus 2 minus 5i, and then x minus 2 plus 5i. That'll give you x squared minus 2x plus 5ix. Subtract minus 2x plus 4 minus 10i. And I'm doing it this way so they can line up with the same ones that they are, so it won't get mixed up. And that'll give you x squared minus 4x plus 4 minus 25 I squared equals negative 25, negative 1. And then you would subtract x squared minus 4x plus 29. And that would give you x minus 1, x squared minus 4x plus 29. We'll move over here. So I just moved this problem to over here. And then you do x cubed minus 4x squared plus 29x minus x squared plus 4x minus 29. That came by just multiplying. And that gives you x cubed minus 5x squared plus 33x minus 29 is to the third degree it'll give you x minus 1, x minus 2i, x plus 2i over x squared. And that's complex numbers and zeros. Now we'll move over to rational functions. With rational functions, this is what the a standard equation would look like, nx over dx. And you would be looking for the vertical asymptote and the horizontal asymptote. And for the vertical asymptote, you only have one rule. The line x equals a, and that would be a vertical asymptote. So let's just say you have x plus 2 over x plus 3. Trying to find x. So it would be negative 3 equals 0. For a horizontal asymptote, you have 3 rules you need to follow to find it. The first one would be the degree of nx is greater than dx. Then there's a ratio of your leading coefficient. So 3x plus 2 over 2x plus 3. If their degree is the same, then you would use the leading coefficient, and the horizontal asymptote would be 3 over 2. The second rule is if the degree of nx is less than the degree of dx, then you will have a horizontal asymptote at y equals 0. So if nx is x but dx is 2x squared, then the horizontal asymptote would equal 0. And the last rule would be if the degree of nx is greater than the degree of dx, then there is no horizontal asymptote. So this degree would be 3, and the horizontal asymptote would be none. And that's how you would find the horizontal and vertical asymptote. And if there is no horizontal asymptote, then you can find the slanted.
Katrina, let's skip this because you're about to run out of time. Maybe just talk about how to find the x-intercept and y-intercept.
Okay. To find the x-intercept, the 0 equals x over dx. So 0 equals fx. You're trying to get the numerator to equal 0. For the y-intercept, it'd be y equals fx over dx. So it could be y equals 0 over negative 2. It would equal 0. Or y equals 3 over 4. So it'll be 0 minus 3, 0 plus 4. That'll equal negative 3 over 4. And that will give you 2 rational functions. So you're trying to find the vertical asymptote, the horizontal asymptote, the x-intercept, and the y-intercept.
Cool.